there, it's Mrs. Sullivan. This is Notes for Section 9.3. We're a little slap happy
We've got
today.
the giggles.
We do. Mrs. Tremblay just sang a really cute song. Maybe someday she'll share it with you. It's an experimental probability. We talked a little bit about this in class. We've been working with something called theoretical probability, which means technical, very mathematical. Experimental probability means, okay, let's actually do the experiment, play the game, and see what happens. So that's what experimental probability really means. So it's the probability that is based on repeated trials, that's like you play the game, of an experiment. It's called experimental probability. So the probability of an event happening is the number of times that an event occurs, all divided by the total number of times. Here's an example. Let's calculate the experimental probability that if there are 13 out of 20 emails in your inbox are junk emails, what is the experimental probability that your next email is junk? Well, if you know that 13 out of 20 that's how many emails are junk, then you know at this point that we're just going to take 13 divided by 20. If you got like 13 out of 20 on a quiz, what percent is that? So you divide this and you get 0.65, and we can turn that into a percentage by quickly multiplying by 100. That's 65% chance that your next email is going to be junk. Example number 2.
I like to keep my junk in the trunk.
Oh, Mrs. Trombley. You're so bad. Example 2. Making a prediction. It rains 2 out of the last 12 days in March. If this trend continues, how many rainy days would you expect in April? All right. You know the little rhyme for how many days are in a month? 30 days has September, April, June, and November. Did you hear April? I did. There are 30 days in April. So if 2 out of 12 days it rains, how many days out of 30 will it rain? This should look very familiar. We're setting up a proportion, and we're going to figure out if 2 out of 12 days it rains, how many out of 30 days would it rain? So we're going to cross products here. 12 times n is 12n, and 2 times 30 is 60. I don't know what to do. I should add them. No, we're going to divide. Divide by 12. So n equals 5. 5 what? 5 days. 5 days of rain in April. I really think there's more.
Yeah, I agree.
Moving on. Example 3.
How many days of snow will we get this June?
What are the chances of that? Extra credit. Put together a presentation on that. Example 3. Comparing experimental and theoretical probability. So experimental is when you actually perform the experiment. Theoretical are what the laws of math say will happen. All right, so if a bar graph shows the result of rolling a number cube, aka a die, 50 times, what is the experimental probability of rolling an odd number? How does this compare with the theoretical probability of rolling an odd number? Well, what is the theoretical probability of rolling an odd number? Well, you know that 3 out of 6 numbers on a die are odd, which is 1/2, which is 50%. So there's a 50% chance, theoretically, that you will roll an odd number. Well, let's look and see what happened during this actual experiment. So all of our odd numbers are 1, 3, and 5. How many times was a 1 rolled? 10 times. How many times was a 3? 8. And a 5 was also rolled 8 times. If we add all of those up, we get 26. It was rolled 50 times altogether. So that means that our experimental probability was that 26 out of 50 times the die was odd. So take 26 divided by 50, you get 0.52, which makes 52%, as compared to 50%. It's not exact, but that's pretty darn close. So when it says, how does it compare? I'm going to put pretty darn close. And we'll see you tomorrow.